This is going to be a tutorial for how to use OpenRocket for the OPHS rocketry team slash class. Um, right now, I am currently using version 24.12. This is a beta version, but it should be relatively the same as 23.09. So to start off, we are going to click on the sustainer and we are going to add a nose cone. Once you pop this up, it'll bring you to a bunch of presets. These presets are based off of actual parts that people have inputted or the developers have inputted. Unfortunately, a lot of the times with our Tark rockets, these are 3D printed parts, so we will manually have to create the dimensions of said parts. So either you already have a nose cone designed in which you can grab the parameters off of that, or you can design one in here and then send that file or use those dimensions to make a 3D print. So right now I am going to bring up a photo on my phone of a nose cone which we are currently using for the TARC competition. So this nose cone is ogive. The length of it is going to be 2.362 inches with a base diameter of 2.64. Wall thickness is 0.079, that is fine. Component material, this gives you a database of materials that they currently have. You can also add your own materials, so I have already added in ABS plastic. So I'm going to go ahead and click on that one. And component finish, this will determine the amount of drag that's put on that part. So if you look at each part, they currently have different mil amounts. And if you wanted to change your rocket to make it go higher or lower, you can change the component finish as well. There's also a coefficient of drag override, which I will show later. So we can change the component finish for now to just unfinished. I am going to click shoulder now, and we are going to add a shoulder. So give me 1 second, and I will pull up the shoulder information. So this is just going to add a little thing to the back over here. Okay. So now we have a nose cone. It's a relatively small nose cone. Please note that if you do want to include an altimeter in here, you are going to need to add either a bulkhead or a lip right here. You can do that by clicking bulkhead. It'll automatically calculate some type of shape. Of course, this isn't the actual diameter of that bulkhead we want. So I can change the position of that bulkhead, just say around there, and increase the diameter so it butts up against the edge of your nose cone. And that would be a bulkhead. So either you can attach an eye bolt here for your parachute and shock cord, or you can add a centering ring instead to add your altimeter. For now, I am just going to delete that. So from this nose cone, we are going to actually need our body tube. So we can click on body tube. It will bring up a database of parts. We are going to use one of these parts now. So for the 2024 to 2025 competition, it requires 2 body tubes of different diameters. So for the first one, I am going to use a T80H-34. This H indicates that it is heavy walled tubing. The T80 is just regular walled, which is prone to crumpling if you have it hit on a hard landing. I'm going to click that. It's going to give you this really long body tube. And I can now change the length of said body tube. Okay. So now our body tube is a bit shorter. From there, we can go ahead and add a transition. So this transition is going to change our body tube diameter. So instead of having it one solid diameter throughout the whole thing, we can have a different diameter for the bottom. Okay, so right here you can change the shape of your transition. I'm going to keep it as conical for right now. And I'm going to change this based off of the 3D model which we currently use for our Tark rocket. It's going to be 2 inches for a diameter of 2.64, aft diameter of 2.245, and a wall thickness of 0.079 is fine for now. Now the shoulder is the important part because that's gonna be the part that you screw in to both right here and either the bottom, not the bottom part, forgive me, you're gonna screw that in to the upper payload bay. So we're gonna change the diameter of the fore shoulder to 2.6 inches, the length of 0.6, and a thickness of 0.062. So you can see that just adds a shoulder to the front. Now the aft shoulder is going to add a shoulder right here. So let me go ahead and add the dimensions of that aft shoulder. This is going to be 2.175 inches, a length of 0.7 inches, and a thickness of 0.062. Again, this depends on what type of tube you're using because these are essentially little couplers to slide into a larger diameter tube. So all of this information would change depending on the type of tube you have. So now that I have a transition, I'm going to add another body tube. This is going to be where our motor mount is going to be glued into, as well as where our fins are going to be. So I'm going to go ahead and click on body tube. It's going to automatically add a body tube to the back. Now for the Tark competition, the lower body tube has to be a smaller diameter than the upper tube. So I'm going to click on the one we are using, which is the T70H-34. Again, it adds a really long body tube to the back. We can change that length right here. I'm going to go ahead and change this length to 14 inches. There we go. Now, if you look at the component finish, I'm going to set that to unfinished for now. I'm going to do the same for that transition and the upper body tube. Again, with the transition, I haven't actually stated this yet, we can change the component material. Since this is 3D printed, we can change it to ABS plastic. Let me make sure that I did the same for the nose cone. Okay. Now we are currently missing a motor mount, our eggs, the foam, and fins, as well as our recovery. So to add a motor mount, we are going to click on inner tube. We're going to change the length. Typically, I make this about 4 inches. It automatically adds it to the back. You can change this position right here, depending on where you glue in your motor mount. Material is fine, it is cardboard, but I am going to change all of the outer diameter, inner diameter, and the wall thickness. So I'm going to change the outer diameter to 1.2 inches, the inner diameter also to 1.2 inches, and I'm not going to set a wall thickness right now. I don't think it matters too much, but if you want to get nitpicky with it, your outer diameter and your inner diameter will not be the same. We're also going to go ahead and click. This component is a motor mount, so it knows that when you input a motor into the simulation, it will place it inside of this tube. I'm now going to go ahead and add centering rings. To do that, we're going to go to Inner Components and click Centering Ring. It brings up a bunch of presets, but since we laser cut these centering rings, I am going to change that manually. These centering rings are made out of plywood, so I can go to wood, plywood, birch. It will also automatically calculate weights of each material for you. However, once you print it, I print laser cut any material, I would recommend overriding the mass and changing the weight of each material. That way it is more accurate. So I'm going to change that outer diameter to match up with the outside of the inner diameter of this tube. That looks about right, but I'm going to go ahead and double check. It should be this inner diameter, which is 2.175 inches. So I'm going to change this 2.175. You can also automatically calculate it, but that did not seem to help. The inner diameter, we are going to set to the inner diameter of the outer diameter of the motor mount. So I'm going to go ahead, go into that motor mount again, and look at the inner diameter, which is 1.2. The outer diameter is also 1.2. So I'm going to set the inner diameter of 1.2. Okay, so we have one centering ring. We are going to need another centering ring. So I'm just going to Control C, Control V, gives you another one, but we are going to add this to the more towards the front. So if you want to center out your centering rings, you can change this position. So this is from the bottom, it's negative 3.6 inches. So I can go ahead and go into here and go 3.6. Oops, I mean negative 3.6. Never mind. Just go ahead and move it manually then. The middle section is where your fin tab is going to go. So now let's make some fins. Click on this lower body tube, and then you can add several types of fins. I like trapezoidal fins, and I can change how they look in the program. Okay, so I now have the fin set configuration for my other Tark file, which I am going to copy onto here. Usually when I'm designing fins, I will just mess around with how they look, and once I like that, I will take those dimensions and make a laser cut of said fins. But since I already know the dimensions of my fins, I am just going to input them here. Root chord, this is the length of this side right here. Tip chord is the length of the top of the fin right here. Height, this is just the height of the fin, excluding the fin tab. Sweep length, this will change which way it's going, like that. I'm going to keep that at 1.8, and the sweep angle I'm going to keep at 31. The fin cross section, so if you look at an airplane, you can see that the wing is rounded in the front and tapered towards the back. If you choose to do this on the rocket, it will decrease the amount of drag. So I'm going to change that to airfoil and change the thickness of the fin to 0.125. Okay, component finish. I'm going to change to unfinished. And the material, this is plywood. Fillets. So this is the area that you bond between the body tube and the fin. I'm going to change this material to epoxy. So I put in epoxy just by Googling the density of epoxy. And then the fillet radius, you can kind of guess on this. It doesn't really matter a whole lot. I am going to say it's 0.063 inches. Okay, now we are going to go on to the fin tabs. So this is what's going to stick inside of your rocket and bond to the motor mount. This makes for a more rigid and robust design that should be stronger. Tab length, 3 inches. Tab height, 1/2 inch. tab position is negative 0.3 inches. I'm going to change this to bottom of the parent component. I'm going to have to change these again to negative 0.3. And it should put these inside your centering rings. I'm going to change this centering ring right here, and I'm going to butt it up against the end of that fin tab. I'm just going to go ahead and move this. Sometimes you got to tinker around with it a little bit. Wrong way. This should be fine for now. Okay, so we got the basics of a rocket right now. We are missing a parachute. So I'm going to go ahead and go into body tube, and I am going to add a parachute. It will come up with a bunch of parachutes. Usually I'll click from one of these. I don't find that the parachute you pick matters too much besides the weight of your parachute. So beforehand, weigh which parachute you're going to use inside your rocket, and then click one based on this data. You can also look at the packaging, and if it is already in your presets, you can use that one. So I'm just going to choose a 12-inch, and that will put it right there. Both our parachutes are going to be in this lower tube because this has to separate into two different parts. One shock cord for the top half and one for the bottom half. Click OK. I'm going to just copy and paste that one and change it to the back. This is a 12-inch chute. I can change it to a 15-inch chute. Why not? So now I have two parachutes, but there's nothing attaching them, so I'm going to add a shock cord. The shock cord we use is not elastic, it is Kevlar. So I'm going to go to threads and lines, Kevlar. There's a bunch of Kevlar. I am not too sure which one we use. You would have to look at the packaging or the receipt from your purchase. So I'm going to go ahead and click Kevlar 1/8 inch. Why not? Shock cord length does matter. Usually you want it 3 to 5 times the length of your rocket. Since this rocket is split in half, I'm going to just estimate it for now. I think this was 12 inches. Let's say that's another 3 inches. Make it 45 inches. Why not? 45 inches for the top. Pack length changes to be a little longer. Change the position down to here. We are going to do the same for the bottom half. So that was, I believe, 14 inches. Times that by 3. You want at least 42 inches of shock cord for the back. Change that to 42 inches. Remember to change this to Kevlar. The material does matter as it increases the weight. You can also just override the weight and put in whatever you find on a scale. And to change that down here, I change the length to make it a bit longer. So it's coming together. Now we are going to need our eye bolts. We have 2 eye bolts for this rocket. We're going to have one attaching the shock cord right here, and another one attaching the shock cord to the centering ring. So to do that, I'm just going to add a mass component. Make sure to weigh your mass components. For now, I'm just going to estimate that one of them weighs 5 grams. We're going to change this to right there, And we can change the diameter and length. Say this is a 16th inch, 1/8 inch eye bolt, and it is an inch long. Change that to be sticking out of here a bit, and click OK. We're going to copy and paste that one, so we have two of them. We're going to move this down. Now it's in the middle. We do not want it in the middle, so I'm going to go to radial position and change that in radial distance. This will move it left and right. So we're going to add it right there. Now we have two parachutes, two pieces of Kevlar, two eye bolts. We are going to need chute protectors as well as quick links. So those are also going to be mass components. Be our quick link. I'm going to estimate that. Remember to weigh these parts yourself before you do this. You can input the density as well if you'd like. I'm going to add that right to the parachute. Copy and paste that and add another one to where the other parachute is. Alright, we got that. Now we are going to need our Nomex chute protectors. I'm going to add that as a mass component as well. I do not know how much those weigh. Let's guess 10 grams for now. Add it right there. I'm going to change the length to make them slightly longer and encompass that parachute. Control C, Control V. Go into here. I'm going to change the position of that to the other one. So we're still missing a couple things. When you look at a rocket, we have a motor retainer on the back, as well as a bulkhead, so this eye bolt is not floating in space. So I'm going to go ahead and add a bulkhead, and then I'll add that motor retainer second. So right here it says bulkhead. It'll come up with some parts. We do not want to use those parts because this is going to be a laser cut thing. Change it to right around there. Make sure this diameter lines up with that inner diameter of that shoulder. I could just look at the other part, but I'll estimate it for now. I believe this was 2.175, possibly. No, I'll keep it as 2.17. Oops. Doesn't matter too much. Material, we are going to change to whole eye wood. So now we have another bulkhead. Make sure your thickness is where you want it. We use 1/8 inch wood. There we go. So now we have a bulkhead. So we are still missing our eggs, an altimeter, that little centering ring, lip, whatever you want to call it, and a motor retainer. So I'm going to go ahead and add that motor retainer in. You can add it as a inner tube. You can also add it as a mass component. Just to make things simple, I'll use a mass component. To do this, I would weigh out two things. I would weigh out that piece of threading which gets glued on to your motor retainer if you are not 3D printing your motor mount. Excuse me, not motor retainer, to the motor mount. And I would also weigh that piece that screws onto that threading. I'm going to estimate it, say it weighs 10 grams right now. Change the position to the back. Change the length and the diameter right there. Call this our motor retainer. Okay. We are still missing eggs as well as the altimeter and that inner lip. So let me go ahead and add those eggs it is going to be a mass component inside of the upper tube. So for the tart competition, our eggs can weigh between 57 to 63 grams and have a length of 60 millimeters. So I'm going to change this to 58 grams, length millimeters. Change this to 55, why not? Make that egg a little longer. Call this an egg. Change that to put it inside our tube. And this has to be sideways, so I should change it this way instead. Oops. That's one egg. I'm going to Control C, Control V, make another, and change the positioning of our egg. So now we have two eggs. I'm going to add some foam because that also adds weight. I'm just going to make that to encompass the eggs. Change the diameter and place that over the eggs. Call this foam. Now you don't have to name your parts, it just helps with organization. As you can see, I'm also forgetting to name some parts. We'll change the mass of this to 10 grams. I'll make these egg, this one egg. Alright, so now we have a more thorough rocket. We're still missing a couple things. We don't have launch lugs. We don't have an altimeter. So I'm going to go ahead and go to that nose cone, and I'm going to add that little lip I mentioned earlier. Instead of doing a bulkhead, I'm going to make a centering ring. Place it lower. Change the inner diameter based on whatever your print is, or whatever centering ring you choose to make. Outer diameter should line up there. And now we have a little lip. Since our nose cone is 3D printed, this will be made out of ABS. Thickness depends on your print, but I'm going to keep that there for now. Now let's add a altimeter. Altimeter I'm just going to keep as a mass component. Say it weighs 7 grams. Make sure to weigh your parts. Change that and put it on that lip. You could change this based on whatever the dimensions of your altimeter is. Radial position, since it is screwed into the side of the centering ring, I am going to change it to the right a little bit. All right. So now I'm going to add some rail guides. So I'm going to go to body tube, click rail button. It'll come up with some presets. You can click this one. It'll automatically create a rail button. I like to have one in the back closer to the motor mount and then one near your center of gravity. So I'm going to change the position, put one of these down. I'm going to copy and paste one and put one on the top. So since in this case we can have a centering ring, or a rail button, sorry, around the center of gravity. So you can either have it right here and add a spacer to both of them to clear the rail and not have this piece impede on your rail, or you can have no spacer on this one and one spacer on this one, and instead place that one up here. We could keep them down here for now. Okay, now we got a rocket. that is essentially done with the actual build part of it. And in the next video, I will go over how to simulate and fly the rocket in OpenRocket.